Hello learners, welcome back. In today's session, we will be moving forward to the topic of plumbing for buildings. Plumbing is an integral part of any building structure encompassing the system of pipes, fixtures and other apparatus required for water supply, heating and sanitation. The efficient design and implementation of plumbing system are vital for ensuring the comfort, safety and sustainability of a building. In this session, we will be discussing firstly about the plumbing system, secondly the water distribution system, the general consideration for laying out pipes, material for service pipe, service connection, pipes and traps and the system of plumbings. Now, let us discuss what is plumbing. Basically, plumbing is an essential service in any plumbing encompassing the entire system of water supply, distribution and drainage. A well designed plumbing system ensures that an adequate quantity of water is available at all required locations within a building, meeting the various needs of its occupants. The process begins with the collection of water from the source, followed by its conveyance to treatment plants, treatment and disinfection, and finally its distribution throughout the building. Once inside the building, water is transmitted through a network of pipes which may run either underground or above ground, ensuring that all areas have access to the necessary water supply. As water is used, it becomes wastewater which must be effectively drained away. This involves a range of sanitary fittings such as taps, valves, wash basin and water closets, all of which play a crucial role in both the water supply and drainage systems. The term plumbing broadly refers to the materials, fixtures and practices involved in the installation, maintenance and operation of these systems. It covers everything from water supply pipes and storage tanks to drainage system, including septic tanks and vent pipes. Together, these elements ensure the proper functioning of water supply and sanitation services within a building, contributing to the healthy, safety and comfort of its occupants. Now, let us discuss about water distribution system. It includes the water collection and its distribution. Firstly, that is service connection. Water is collected from the main supply via service connection, which will be dealing in the next slides. Water distribution layout. It is horizontal or vertical arrangement. Water distribution piping can be laid out horizontally or vertically within a building. It typically involves underground mains that are under pressure, supplying water directly to fixture inlets. Next is the unfeed system. This type of direct supply system, where water is fed under pressure directly to the fixtures, is known as unfeed system. Alternative water supply methods include the suction tank system and the gravity feed. So, we will discuss suction tank system. Water is first collected in an underground water, also known as suction tank. It is then pumped to elevated storage tanks located at the top of the building. Next is gravity feed. From the elevated storage tanks, water flows downward due to the gravity. This system allows water to feed the various fixtures throughout the building. Now, there are some general consideration for laying out pipelines. So, when laying out pipelines, the following consideration should be observed, which are firstly preventing water contamination. So, we have to ensure the water supply remains uncontaminated by adhering to these guidelines, which include firstly, we have to avoid any cross connections between pipes carrying potable water and those carrying used or wastewater. Secondly, we have to prevent backflow from any cistern or appliance into the main water supply. Next, to water supply pipes and wastewater pipes should not be laid too close to each other. Next is the protecting the pipeline. Pipelines must be properly protected from the damage. Underground pipelines enclosed in cement mortar to prevent rusting from soil bacteria. We have to provide an earth cover of at least 60 centimeter, And above ground pipelines, we have to ensure the pipeline runs clear of any water exposure. When crossing a wall, the pipeline should be contained within sustainable or suitable sleeve for the entire length of crossing. Next is maintaining adequate pressure in unfit system. So, for unfit system, we have to ensure that the pipeline carries water under adequate pressure by following these practices, which include you have to keep the layout of the pipe as simple and direct as possible. We have to lay the pipes in as straight a line as possible to avoid unnecessary pressure loss. Next topic we will be dealing is the estimation of water requirement. For residential buildings, Indian standard recommends that a water requirement of 135 liters per head per day may be assumed. Out of this, 90 liters may be taken for domestic purposes, while the balance 45 liters are taken for flushing requirements. The requirements of water for buildings other than residence may be found from this table. As you can see in this table, in the first column there is type of building, and in the second column there is the rate per head per day in liters. For example, factories where bathrooms are required to be provided. So, in that their rate is 45 per day per in liters per head in liters. Next, if we consider hospital, which includes laundry per bed, firstly number of beds not exceeding 100 beds. So, there is rate is 330 per head per day in liters. For schools, if there is day school, then rate is 45, and if there is boarding school, rate will be little higher, which includes 135. Next is material for service pipes. The pipe that connects the distribution main of a municipal water supply to house plumbing system is referred to as the service main. Commonly used material for service pipe includes copper or brass pipes, galvanized iron pipes, lined or unlined, lead pipes lined or unlined, and next is polythene pipes. So, first we will be dealing with copper tubing. Copper tubing is widely used because it is resistant to corrosion in most water types. It is especially popular in high quality homes and area where groundwater is highly corrosive to steel pipes. Copper tubing offer considerable strength, good ductility, and is available in long lengths. There are two main types of copper service pipes, which are heavy gauge and light gauge. Heavy gauge copper pipes can be threaded and are typically used in high pressure industrial settings. Next is the light gauge tubes, on the other hand, are used for general purposes where the pressure does not exceed 0.15 Newton per mm square and are suitable for internal domestic applications. For underground installation, such as the pipe running from the main to the building, a special heavy gauged copper tube is used. This type of copper tubing can be directly connected to the main without the need for a conventional gooseneck, using a flared end to attach directly to the corporation cock without threading. Next pipe is galvanized iron pipes, that is GI pipes. GI pipes are widely used in India due to their cost effectiveness compared to copper tubes. They are suitable for use in water condition where corrosion is less of a concern. However, galvanized iron or steel tubes are more prone to corrosion in soft and acidic water, while they are stronger and more suitable for hard water areas where they can endure the force required to remove scale. They are not as easily manipulated as copper pipes. Next pipe is lead pipes. Lead pipes offer several advantages, including they are highly resistant to corrosion, extremely flexible, and have a high hydraulic coefficient of flow. Despite these benefits, lead pipes are not preferred due to the risk of lead poisoning, which can accumulate over time, especially if the lead dissolves into the water. Next tubes or pipes are polythene tubes. Polythene tubes are increasingly being used for both internal and external cold water service pipes. Compared to metal piping, plastic pipes have several advantages. They are more cost effective, non-corrosive, lightweight, easy to install with standard tools, do not require threading, are more resistant to bacterial scale and offer some insulating properties. However, polythene pipes are not suitable for high temperature applications. Next topic we will be dealing is service connection. So, what is service connection? It refers to the link between the distribution system and the consumer, who could be an individual house, an apartment building, a planned community or a water district purchasing water in bulk. For a single house, this connection typically involves tapping into main supply while it is still under pressure and installing a corporation cock. A domestic service connection generally includes the following components, which are firstly the brass or bronze ferrule. A ferrule is a right angled sleeve made of brass or bronze. For a standard house service connection, the ferrule is inserted into the main supply pipe. This is often done while the main is under pressure, meaning the connection can be made without shutting down the entire water main. Next is the gooseneck. The gooseneck is a 40 to 50 centimeter long curved piece of flexible pipe made of brass, copper or lead. It provides flexibility at the junction between the water main and the service pipe, preventing the main service pipe from breaking due to any movement between the two. Next is stopcock or curve valve. This is a valve installed in a chamber with a cover, allowing the water supply to be shut off when necessary, such as during plumbing repairs. Main service pipe. This pipe can be made from various materials as discussed earlier. The diameter of the main service pipe typically ranges from 12 mm to 40 mm. Next is the water meter. The water meter is installed in a chamber with a cover and is used to measure the amount of water consumed by the user. A water meter is typically used to measure the flow of water to residential buildings. An effective water meter should have the following characteristics. Firstly, it must accurately measure and record both small and large water flows. It should be easy to maintain and repair with spare parts readily available. The meter should have good capacity while maintaining a reasonable head loss. It should function efficiently at all pressure levels. The meter should be durable with components resistant to chemicals used in water purification and impurities present in the water. It should be sturdy and robust. The meter should prevent backflow and should not be prone to clogging. It should be cost effective. Basically, water meter used in distribution system can be classified into two types. First is inferential or velocity meters and second is positive or displacement meter. So, what is inferential or velocity meters? These meters measure the velocity of flow of water through a cross section with a known area. They are typically used for high flow rates. Common examples include rotary meters and turbine meters. Positive or displacement meter. These meters are primarily used for lower flow rates such as in residential buildings. They measure the actual volume of water passing through by filling and emptying a chamber of known capacity. Various types of displacement meters include reciprocating, rotary, oscillating and nutating disc meter depending on the motion of the internal component. One example of the displacement meter is the disc meter. This type of meter contains a disc made of hard rubber placed inside a chamber with inlets and outlets. As water enters the chamber, it causes the disc to oscillate in a spiral motion around its corner. The oscillation from one complete cycle of filling and emptying the chamber are recorded by the disc meter as the volume of water passing through. So, in domestic water supply system, there are mainly two types of valves are used. Firstly, globe valve and secondly is gate valve. So, first we will discuss about the globe valve. This valve is typically used in pipelines to manually control and stop the flow of water. It should be installed so that the water pressure is applied under the valve seat as illustrated in this figure. The globe valve has several advantages, which include quicker opening and closing, a longer lifespan and ease of repair. Secondly, the gate valve. The gate valve is also used in pipelines to manually control the water flow. It has an advantage over the globe valve in that it offers less resistance to the flow of water. This makes it preferable in situations where minimizing the flow resistance is important. Additionally, the gate valve can effectively control the flow of water in either direction. Next topic is storage tanks. So, water supply to a building can be either continuous or intermittent. Even with a continuous supply, the water pressure might not be sufficient to reach all the floors of the building. In such cases, storage tanks become necessary. These tanks can be located at ground level, roof level or both. So, if the water pressure is sufficient to reach the roof, a storage tank is placed at the roof level to store water during intermittent supply periods. If the pressure is insufficient, water is first collected in a ground level tank and then pumped up to the roof level tank. So, storage tank can be constructed from the following materials, that is the mild steel pressed plate, secondly the reinforced concrete, stone or brick masonry. This figure illustrates a typical storage tank. So, a storage tank includes the following component, which includes firstly the top cover. The cover is made from mild steel, aluminum or another suitable material. It should be lightweight and fit tightly to prevent mosquitoes from entering. A locking mechanism may also be included. Next is ball valve with float. This is installed near the tank's inlet to regulate the inflow of water. The float assembly operates automatically to maintain a constant water level. When the water level drops, the float descends, opening the inlet valve. When the water level reaches the full supply level, the float rises, closing the inlet valve. Next is overflow pipe. It is positioned about 2.5 cm above the full supply level. This pipe allows excess water to escape in case the float assembly fails and the inlet valve remains open. Next is the supply or inlet pipe. This pipe is responsible for bringing water into the tank. Next one is outlet pipe with stop valve. It is located about 2.5 to 5 cm above the tank's bottom. This pipe allows the water supply to be shut off when needed. Next is drain or scour pipe. This pipe is used for periodically cleaning the tank. Next topic is house drainage. There are some general principles which we have to study. Firstly, we will discuss what is house drainage. It refers to the system within a house or building designed to collect and convey wastewater through drain pipes using gravity to connect either to a public sewer system or a domestic septic tank. So, basically what are the aims of house drainage? Firstly, to ensure a healthy environment within the building. Secondly, to quickly and efficiently dispose of water, to prevent the entry of foul gases from the sewer or septic tank into the building, to facilitate the rapid removal of waste such as human excreta, to systematically collect and remove waste materials. Now, let us discuss what are the principles of house drainage. For an effective drainage system, following principles are observed. First one is the optimal location of lavatories. Lavatory blocks should be positioned to minimize the length of the drainage line. In multi-story building, they should be stacked vertically. at least one wall of the lavatory block should be external wall to allow for the installation of soil and vent pipes. Second one is drain pipe placement. Drainage pipes should be laid alongside the building rather than underneath it. Next one is straight drain alignment. Drains should be aligned in a straight line between successive inspection chambers. Sharp bends and junctions should be avoided unless they occur within the chambers. Next is the sufficient drain slope. Drains should have an adequate slope to maintain self cleansing velocity. Next is the adequate drain size. The drain size should be large enough to prevent flooding during peak discharge. Next is the use of traps. The drainage system should include sufficient number of traps at appropriate locations. Next is the disconnection from public sewer. The house drain should be separated from the public sewer by an intercepting trap preventing the entry of foul gases into the house drainage system. The public sewer should be deeper than the house drain. Next one is the rainwater management. Rainwater pipes should be direct rainwater directly into street gutters, where it can be carried away to the storm water drain. Next point is water tight connection. All connection within the drainage system should be water tight. Proper ventilation, that entire drainage system should be well ventilated from starting point to the final disposal point, allowing for free air circulation. Now, we will be dealing with the topics of pipes and traps. First, we will discuss about pipes. In a house drainage system, pipes are designated based on their specific function. First one is soil pipe. It is a pipe designed to carry human excreta. Next one is waste pipe. It is a pipe that carries only liquid waste excluding human excreta. Next one is vent pipe. This pipe is used for ventilating the drainage system. It is open at both the top and bottom, allowing foul gases to escape. The vent pipe extends at least 1 meter above the roof level. Next point is the rainwater pipe, a pipe that is specifically used to carry rainwater. Next one is anti-siphonage pipe. This pipe is installed in the drainage system to maintain the water seal in traps preventing siphonage. The typical pipe sizes used in house drainage system are: soil pipe will be of around 100 mm, horizontal waste pipe 30 to 50 mm, vertical waste pipe 75 mm, vent pipe 50 mm, and the anti-siphonage pipe, in which connecting to soil pipe will be of size of 50 mm and connecting to waste pipe will be of diameter 40 mm. Next is traps. A trap is a curved or bent fitting in a drainage system that remains filled with water, creating a water seal. This seal prevents foul air or gases from passing through, while still allowing sewage or wastewater to flow. The water seal's depth is the vertical distance between the highest point and the lowest point of the trap. The effectiveness of a trap increases the depth of its water seal, which typically ranges from 25 mm to 75 mm. Now, what are the causes of seal blockage? The water seal in a trap can be compromised due to the faulty joints, the cracks at the bottom of the seal, the creation of partial vacuum in the sewer fittings, increase in the sewer gas pressure, prolonged disuse. To prevent the water seal from breaking, it is advisable to connect the section between the soil pipe and the trap with a vent pipe and to use an anti-siphonage pipe within the building. Now, what are the characteristics of a trap? So, a good trap should have the following features, which include that it should maintain a sufficient water seal at all times while retaining only the minimum necessary water. It should be made from non-absorbent material. It should be free from internal projections, angles or construction that could impede or slow the flow. It should be simple in design and affordable and readily available. It should have self-cleansing properties. It should be equipped with access point for cleaning, and it should have smooth internal and external surfaces to prevent dirt buildup. Now, there are some classification of traps according to the shape, which are P trap, Q trap and S trap. So, what are P trap? They are basically shaped like the letter P with legs positioned at right angles to each other. Next one is the Q trap, that is which can also be called as half S trap. It is shaped like letter Q with legs meeting at an angle other than 90 degree. Next one is S trap. It is shaped like letter S with parallel legs discharging in the same direction, and it can also be classified according to the use. First one is the floor trap, Nani trap. It is used to collect wastewater from floors, kitchens and bathrooms, typically made of cast iron with a grate on top to prevent large debris from entering. It has a removable cover for cleaning and a small water seal. Next one is the gully trap. It disconnects sewage drains from the main drainage system, usually made of stoneware or cast iron. It includes a water seal of 60 to 70 mm and may feature either an S trap or P trap. It is typically installed at the external wall of a building to receive wastewater from baths and kitchens before passing it to the house drain. Next one is the intercepting trap. It is installed at the junction where the house drain connects to the public sewer or septic tank. It is located in the last manhole of the house drainage system. It has a deep water seal of 100 mm to prevent sewer gases from entering the house. It includes a cleaning eye or rodding arm with a tight fitting plug for easy maintenance. Next one is the grease trap. It is used in large hotels, restaurants or industries where significant amount of oily waste are produced. A grease trap, usually made of masonry or cast iron, which reduces the flow velocity, allowing greasy matter to separate and float on top, where it can later be removed. Next one is silt trap. It is used to remove coarse particles of silt and sand from wastewater before it enters the building drain. Similar to a grit chamber, a silt trap is often combined with a grease trap to ensure efficient removal of solid particles. So, our last topic is system of plumbings. Basically, there are 4 primary plumbing systems used for building drainage. First one is single stack system. This is the most straightforward system where waste from bath, sink and toilet is directed into a single pipe known as the soil and waste pipe. This pipe also serves as a vent at its top, so no additional vent pipe is required. The system is only effective if the traps maintain a water seal within a depth of at least 75 mm. In this setup, gully traps and the separate waste pipes are eliminated. The single stack system is economical and simple because it uses only one pipe. Next system is one pipe system. In this system, an additional vent pipe is provided and the traps for all water closets, basins and other fixtures are fully ventilated. In multi-story buildings, the lavatory blocks on different floors are aligned vertically, allowing waste from various floors to be carried through a common soil and waste pipe. This system is more expensive than the single stack system due to the extra vent pipe. Next system is partially ventilated single stack system. This is a variation of the single stack and one pipe system. Here, waste from water closets, basins, sinks, etc. is discharged into a single soil and waste pipe. Additionally, a relief vent pipe is provided to ventilate the water closet traps, but the traps of basins and other fixtures are not directly connected to the vent pipe. Next system is two pipe system. This system involves separate soil pipes and waste pipes. Waste from toilets is directed to the soil pipe, while discharge from bath, sink and lavatory basins is routed to the waste pipe. All traps are fully ventilated with separate vent pipes. Thus, 4 pipes are required in this system. The waste pipe is disconnected from the drain using a gully trap. Our last topic is anti-siphonage pipe. An anti-siphonage pipe is installed to preserve the water seal in traps by maintaining proper ventilation and preventing siphonic action from breaking the seal. In multi-story buildings, when water is flushed from an upper floor, it can create a suction effect that draws air from branch pipe connecting the lower floor's toilet to the soil pipe. This suction creates a partial vacuum on the downstream side of the water seal in the lower toilet, potentially breaking the seal by siphoning the water out. To prevent this, the crown of the trap is connected to the atmosphere through an anti-siphonage pipe. A ventilating pipe can also serve as an anti-siphonage pipe, as you can see in this figure. So, dear learners, we have reached the end of today's session. I hope you found it informative and engaging. Thank you for attention in this session. See you in the next class. Thank you.